All right, I'm going to start recording here and see if I can edit this bit out. But let's go ahead and get to it. All right, guys, I want to talk to you guys about magnetism a little bit, like permanent magnets and magnetic materials. So, in permanent magnets, we've talked a little before about how you can generate a magnetic field with a current, right? So, usually a current in a wire or something. Um, but a current is functionally just a bunch of electrons moving, right? So, you can actually generate a magnetic field, a small one with just a single electron, as long as it's still moving. If it's moving in a circle in the same area, it's going to continually generate a magnetic field. Um, and so we can actually get magnetic fields caused by the spin of electrons in atoms. Um, there's some real hairy details in here about atomic models and things, but we're just going to use the Bohr model for now and say that's good enough instead of worrying about all of the quantum mechanics stuff. So we'll just talk about electrons orbiting a nucleus. And so that orbit can create the magnetic field. So in permanent magnets, there's no reason for those, just in normal materials, and there's no reason for those electrons to spin in the same direction. It just kind of points all over the place. The picture on the left, right? So this guy. And in permanent magnets, they all sort of align together, so they all work together. You sometimes get some that are doing something else, they're doing their own thing a little bit. But overall, the net effect is that they're all pointing the same direction. And the more that point in the same direction is the stronger the magnet you have. So there's different types of magnetism. And we care a little bit about the different types. So let's just try and go through them real briefly. The first type is paramagnetism. And so that's objects with unpaired electrons. So you have that one extra electron that's kind of doing its own thing. So we actually, in this case, we were kind of need to consider that spin of the electron itself. Because if you guys learned in chemistry, in your electron orbitals, you get one spin up and one spin down. So each of those cancel. The magnetic field in each of those cancel. But when you have that one extra, that spin can, have an effect. And if you can get them all spinning in the same direction, you can make a magnet. And so all those magnetic fields add together and contribute to it. So some examples of this: aluminum, platinum, sodium, calcium, crown glass, and oxygen. Now, ferromagnetism is the type of magnetism that iron has. It is a special case of paramagnetism. And when most people talk about magnetic materials, you talk about ferromagnetism. And that's the big difference is it has magnetic domains. Instead of talking about individual atoms and having them point together, it generally has kind of regions that point that generally in the same direction. So it's more like larger chunks. And that we call those chunks magnetic domains. And so most of the time, if you pick up a random piece of iron, they're not pointing all in the same direction. They're pointing all over the place, like the picture on the left. But when you expose them to an external magnetic field, that magnetic field is going to turn the direction of all of them. This is why iron is really easy. You can put a magnet on, pick it right up. So because those magnetic fields turn, and so they'll align, generate a magnetic field of the iron. So then when I put the magnet on it, it sticks together north to south, and they attract. And if I take it from the other side, and then the magnetic fields turn, the magnetic domains turn the other way, so it creates a magnet with the north side on the other side, or the south side on the other side. That's why it's a really powerful magnet, and really useful for things. Of course, the quintessential example is iron, but some other examples are cobalt and nickel. So diamagnetism is the last type we're going to talk about. And diamagnetism is objects that create magnetic fields that oppose the external field. So diamagnetic materials say they were going to try and push the magnetic field out of them. They're always going to oppose them. Whereas like ferromagnets and paramagnets are usually going to line up and point in the same direction as the field. Diamagnets are going to behave the opposite. So, I mean, some important things to know, I guess, is they have no unpaired electrons. And so if I look here in this middle line, when I apply that magnetic field, they all like to point anti-parallel or against it. And it'll be very weakly repelled to magnets. And then down here is just a demonstration. If I put them in an external field, it tries to push that field out of it, whereas a paramagnet or a ferromagnet will draw that field into it. All right, and that's all we got today on different types of magnetism, guys. I will see you in the next video. Have a good day and stay safe.